This module begins our study of evolution. Have you heard that birds may have evolved from dinosaurs? Scientists think that they share a common ancestor.
What's a common ancestor?
A common ancestor is a predecessor that one organism shares with another. It is an organism from which other organisms are evolved. Today's organisms may share a distant but common ancestry.
How do we know that organisms share these common relationships?
Well, we study fossil records to see how much organisms have changed over time. A fossil record is all the traces or remains of organisms from around the world.
Isn't sedimentary rock where many fossils are found?
Yeah, that type of rock is at the surface layer of the earth and has preserved many trapped organisms. We use radioactive dating and relative dating to determine the age of a fossil when found.
What's the difference?
Well, relative dating is comparing the positions of the fossils in the layers of rock to determine their age. Radioactive dating is measuring the age of a fossil through the amount of radioactive material left in the fossil.
So both types are used to see how old the fossil is.
Correct. In relative dating, fossils are arranged in sequential order because of the buildup of material over the top of them for millions of years. Hence, the oldest will be at the bottom.
So what evidence do we have to support this?
We can study the similarities and differences in bones, shell shapes, and other features over time. These are called homologies.
What's a homology?
A homology is when organisms share similarities with each other that point to a common ancestor. Different species had a common ancestor and were closely related at one point. For example, the woolly mammoths and African and Asian elephants share a common ancestor based on their DNA.
Okay, but are there different types of homologies?
Yes, I'm so glad you asked. Molecular homology shows similarities in DNA and other biomolecules, like proteins that make up our cells.
So molecular homology has to do with DNA being similar in organisms?
Correct. And then we have anatomical homology, which is similarities in anatomical structures like our skeletons.
I remember that skeletons are similar to each other in a lot of different species in mammals, like birds and reptiles.
Yeah, that's pretty much all it is. The last type that we have is developmental homology, and we see that in patterns of development. An example is at some point in their development, all vertebrate embryos have a tail, buds that become limbs, and pouch-like gills.
So as an embryo, humans have the same developmental features as a chicken or a dog? That's crazy.
Yeah, it's pretty weird. Biogeography is another type of evidence for common ancestry. It is the study of past and current organisms and where they have lived on Earth. Isolation and separation of members of the same species can cause adaptations.
So can one species on one continent be similar to another species on a totally different continent?
Yeah, the basis for this is the theory that Pangaea, one massive continent, broke apart and separated into large chunks of lands called continents. Alfred Wegener noted that similar fossils were found on both sides of the ocean. He said that at one time the land had to be connected and continental drift had to occur.
So continental drift caused new species to evolve from older species.
Exactly. As the land masses of Pangaea drifted apart, over time newly isolated species developed characteristics that set them apart from their common ancestor.
Have you ever wondered what can explain the diversity of life on Earth? Here is evidence of life on Earth preserved in fossils. A couple more fossils, a flying reptile and fossil in amber. A process called radioactive dating tells the age of fossils using a chemical measurement. Another type of telling the age of fossils is using sedimentary rock and seeing the position of the fossil located in the rock layer. This is called relative dating. Another form of evolution is gradualism, where change is slow and steady, as in the shape of these shells. Fossils give us evidence of life from long ago. This illustration shows anatomical homologies, or similarities in skeletons of different vertebrates. Vestigial structures are structures that do not currently have a function. For example, whales have leg bones inside of them, although they don't walk on land. There was a time when they did walk on land in the past. These photographs show developmental homologies. Vertebrate embryos are compared here. Look at the chicken, possum, cat, bat, and human embryos for similarities. Alfred Wegener proposed a theory of continental drift to explain why fossils were found on different continents that were separated by oceans.